Part C, is this x we found in part B, is it unique? Well, no, we discussed this in part B. There was a free variable, so I chose z to be 2, could have chosen z to be 0 or negative million. So I have many different options. No. There were infinite solutions. In B. Okay, D. So in part D, what are we doing? We want to find if this guy is in the range of A. What is the range? The range is the collection of all images. So what is an image? So we'll say, we'll rephrase this, i.e., does C equal an image in this case? In other words, i.e., does T of x equal C for some x in R3? Well, how do I figure that out? Well, i.e., is AX equals C consistent? And without doing any calculation, just remembering what happened in part B. Well, in part B, we saw that A, the matrix A on its own, has a pivot for every row. So in part B, we saw that A has a pivot for every row. So you'll remember we had a theorem which said that if A has a pivot for every row, then AX equals whatever is necessarily consistent. Okay. So this happens a lot in mathematics. You have a initial question which you kind of rephrase until you arrive at a phrasing that you're able to understand or able to answer easily. Okay, part E. So we have this transformation. T is going from Rn to Rm. So what does that mean? It means that this is like a machine. It takes a vector from Rn and it spits out a vector from Rm. Now, how can you sort this out? Well, so maybe I'll break down the logic here. I would say well, T of x is equal to AX. So we have a matrix times a vector, a matrix vector product. How can that make sense? Well, this is A, it has 1, 2, 3 columns. So for this product here to make any sense, I'm going to need 1, 2, 3 rows here in my vector x. Therefore, this n is 3. So again, just as simple as this. This product is not going to make sense unless I have the same number of columns here as I have rows here. A has 3 columns, so this guy must have 3. So this vector x must have 3 entries. So the vectors that are going into my machine, t, must have 3 entries. And what does it spit out? Well, we have seen that when you have a 2 by 3, and then you have a 3 by 1, then the answer is going to be you exclude the middle, right? So these 3's have to be the same for the product to make any sense. And the result is by taking these exterior numbers, the 2 here and the 1 here. And this 2 here tells me that this vector that's being produced by t has 2 entries.